Okay, guys, we stopped on the empirical formula all the way. I think I think we stopped on this example. On this example, yeah. So let's look at this example here. And as I said, I'm repeating myself. What is the difference between molecular formula and empirical formula? Molecular formula give you the true ratio of the elements within the compound. Empirical formula give you the reduced ratio of the elements within the compound, but it does not give you the whole thing. So now we have an example here. So this example here we can use. So here it is. We have a compound contains dioxide, contains only carbon, hydrogen, oxygen. I give you the sample amount. This is the whole sample amount, which is here. Let me go for just bear with me a little bit. So give us this amount here for the whole sample, correct? So as I said, we have the chapter 3 and 4. Those are most important chapters in stoichiometry. That's where the students, they have some problems, calculations. So that's because the perception is chemistry has no math. No, chemistry has math. Because if you make a mistake in the lab, you can hurt yourself a lot, correct? So that's the whole thing. So you have sample is 0.95 grams. This is the whole sample, dioxide. You are burning this, you are combusting this, and then out of the burning, you get carbon dioxide, this amount, and you get H2O, that's complete combustion assumed, this amount. And then you have the molecular mass is this one here. So you have the molecular mass given to you, this amount here, grams per mole of this. So this is a molar mass. So the molar mass of the whole dioxane, so here it is. Molar mass, just bear with me. Sometimes it does not want to write very well. So molar mass is 0.5. Sometimes the mouse is much better than the pen. 5, 3, 2 grams divided by the 6.04, the mole, 604, 10 minus 3. So this is grams, and this is moles. So this is the molar mass of the whole sample. This is the molar mass of the whole sample. So we know the whole mass. Now we have to look into the whole thing. We have, after complete combustion, we have always carbon dioxide and H2O. Now, the whole idea is, what is the actual molecular formula of dioxane? Dioxane, how does it look like? Well, it turns out to be, if you look at the whole thing here, so you have this amount of grams, and then you need the number of the atomic, this is the molar mass of CO2. Why? Carbon is always 12. It is. Carbon is 12. I'm using the mass much better than carbon 12, and oxygen is 16. Oxygen is 16 gram per mole. You have 2 oxygens, 32 plus 12 makes 44. Correct? That's the molar mass of CO2. Then you make a ratio of carbon. How many moles of carbon in 1 mole of CO2? You have 1 mole of carbon atom to 1 mole of CO2. Look at the CO2 here. CO2. You have 2 moles of oxygen. The ratio, this is 2. And carbon, understood, not written, this is 1. So this is this ratio to get the mole of, we need to get the grams first. So this is up to here to get the mole. So then you multiply it by the by the atomic mass of carbon. Atomic mass, it is atomic mass. So you get atomic mass is 12 gram per mole. So you see how nice is gram CO2. We went from CO2, cancels with the gram CO2. Moles of CO2, correct? So moles of CO2 cancels CO2. Moles of carbon here goes out more, you get number, this is the grams. This is because we need to know what's the oxygen grams so we can determine the ratio between the moles of carbon, hydrogen, and oxygen. So here it is. This came out to be for carbon. This is amount of grams of carbon. For the hydrogen, you have this amount of H2O. That's the molar mass of hydrogen, correct? Hydrogen is 1 gram per mole, the atomic mass of it. So 1. So H2O, you have 2 H2Os, 2, and the oxygen 16, that's 18. This is the 18 here. This is the 18. That's the molar mass of H2O. How many hydrogens we have? We have 2 hydrogens in 1 mole, 2 moles of hydrogens. It is, oops, sorry. So you have 2 moles of hydrogen to 1 mole of hydrogen. Then you use the atomic mass of hydrogen to get the grams. This is the grams of hydrogen. This step is crucial because we need to know the oxygen. We need to know the oxygen. So doing this, the oxygen will be just the difference between those two here. Will give you the amount of oxygen in grams. Now we have the grams here. What you will do then you have to 3 grams, 1 of carbon, 1 hydrogen, 1 oxygen. Use the atomic mass of each of those elements. Then you can turn out to number of moles. So carbon is 12. This is number of grams we calculated for carbon in CO2. This is the atomic mass of we divide by atomic mass to get number of moles. This number of moles, correct? Then you have hydrogen. This amount of grams you have divided by its atomic mass, you get this number of moles. Oxygen, you have this left from the calculation here. Remember, subtraction of those two values to get this number of grams. Divided by this is a typo here. Make sure you understand. Oxygen is not 12. This is a typo. I have to tell another professor which that has to be corrected. So this is 16. 12 is carbon. So 16 has to be 16. So this divided by 16, you get this. Now, this is the empirical formula with fractional. So we need to get it what? To get it the whole number. So whole number is, this is 0.002 divided by the least. This is 0.043, this is 0.07. This is the least one. So you divide all those by the least number. This is 1, correct? This one is 2, correct? No fraction because there is no fractional atoms. And this is, how much is this? This is, somebody will tell me how much is this? Like 4, correct? 88 point, yeah, this is 4. So it looks like, looking like this, carbon is 2, hydrogen is 4, and oxygen is 1. So we go further with this. We take this one out. This is the molar, and this is the, what we say, this is the fractional one. We have to divide all those by 0.022. So you divide all those by the same number, by by the least number. So this one here, and you divide this one here, the same thing, 0.0022. So this will give you the actual empirical formula of the compound itself. Now, if you look at this, the molecular weight, I showed you, this is from the, let me go up here. Here it is. Let me go here, show you the molar mass, how we get the molar mass of this dioxane. Well, it turns out to be the molar mass is number of grams divided by number of moles. Number of grams divided by number of moles. So that the molar mass is mass over grams mass divided by number of moles to get gram per mole. So you divide those two together to get the mass. It is. That's the mass of it. This is 88. Correct? And now the empirical formula came out to be the same thing I told you. So the empirical formula for dioxane came out to be C, carbon is 2, hydrogen is 4, and oxygen is 1. Correct? So you multiply, you do the molar mass of this empirical formula, it came out to be 2 for carbon, 4 plus 4 for hydrogen, plus 1 for oxygen. So you can calculate the whole thing and you can verify this one yourself. This is 12, correct? This is 12, 2 multiplied by 12. This is 1, this is 16. So if you multiply the whole thing, you will see 24 and 4, 26, 26 and 16, this is 44. So this is the molar mass of the empirical formula. But this is the whole thing of the molar mass of the whole molecule. So the ratio between them is 2, correct? The ratio of those is 2. So what you will do here, instead of having this, here the whole thing, you multiply it by 2. So this is the empirical formula, but the ratio between them, 2. So your compound will be C4H8O2. As a matter of fact, the compound will be looking a little bit cyclic, looking like this. That's oxygen here. Another oxygen is here. And another oxygen like this. Not aromatic. It's a cyclic with 2 oxygen there. So you'll ask yourself, 2 oxygens and 4, and the hydrogen is really hydrogen is going here, dangling here. This is hydrogen, 2 hydrogens. This is another 2 hydrogens. It's another 2 hydrogens. 6, there's another 2 hydrogens. So this is oxide. Somebody will tell me why it's useful this compound for in the lab. This is a very good solvent. Since it has 2 oxygens, but slightly polar, and it's solvent. Okay, guys, so let's look at the other one. So we'll go for the other one here. Compound called ethylene glycol. Glycol is antifreeze. That's what you buy from the auto or any. Press is so it at whole H2O will be like a rock. So the whole pipe, the whole tubes for transferring H2O. And, so Dr. Te, you know the material, so you know how this look like. I did not even look it up. Ethylene glycol. OH here is dialcohol, but it's not direct. But you cannot drink rubbing alcohol, isopropanol. You cannot drink methanol. Methanol can cause blindness and death. This one can poison your stomach, so it's not highly toxic like methanol, but still those are high. Now, tell me how many carbons we have here. So we can check our calculation. So how many carbons we have? The molecular formulas. 4, 5, 6. Are they 6? I see 6. 6. 2. So this is the molecular formula. The whole molar, and if we go just the whole molecular formula. Now, if you want to get color, so maybe put another color here, blue. So what will be? Somebody will tell me what's the empirical formula of this compound. That's the next quiz, guys. The next. So what will be? C what? C1 divided by the common number. The common 1 H how much? 3. And oxygen how much? 1. This is the empirical formula. The smallest ratio of the element within the compound. The big one, C2H6. See if we can get into this C1. The molecular weight of ethylene glycol is 16.07 grams. What's not the unit of the molar mass? Gram per what? Per mole. So there is dash mole. So this has to be 62.07 gram per mole. So gram per mole. So this is, let me take the out. See, so we find some typos here. Work is the pressure. We have to finish. We have to finish so the students can save a lot of money. So that, you see some typos. The publisher, they will not have. So that's not fair. But it's understood. This percentage, you assume that the sample is 100. transfer the grams into with some atomic correct? Oxygen is 16 as well. So I'll let them know this. But even if the publisher, believe it or not, we find some typos. We find in the test bank some errors. One of your students pointed to me that there is an error inside the test bank. I looked at myself. I copied as is without looking at the answers. But some answer, I think quiz number one of the answers not correct. I will adjust. So, but for us, it's not that bad. I mean, we have some few, but even the publisher with all the money spend the hundreds of dollars to publish a book, so that's the reason their investment. So they have to return with profits, correct? That's the way it makes business. So I can understand their point of view. But we are looking for our fast food students in general. They are losing a lot of money for books they will never use. You'll be not a chemist, correct? Measuring chemistry, then pharmacy. They go for bio. So chemistry and physics, a lot of students have some reason. Difficult, I think, difficulty of both subjects. So now there's a typo. We found the typo. So now what should I do with those? Which one is the smallest? Is this one correct? So this one here divided by itself, this is 1. So carbon is 1. Hydrogen is how much? 3. Yes. And oxygen is 1, correct? Did I put this one here? C1, H3, O1, correct? Now from this here, 1 here, by the way, I have to get the mole. That's the empirical formula. What is the molar mass of this? Or molecular weight, molar mass. Molar mass of this, you have 1 carbon plus 3 hydrogens, 1 carbon, 1 carbon, plus 1 oxygen. So I'll take this one here. One has to be in front. So 1 is here. So this is 12. 12, correct? This is 1 gram per mole. This is 16. You add them up, how much they are? This is 3, multiplied by 3. 3 and 16 and 3 and 12. So it makes what? Calculated. You can see it here. 1. Sounds good. It's 31. Okay, sounds good. So now the molar mass given to us is 62 for the whole thing. So if you look at this, this is for the whole thing. This is the molar mass of the whole molecule. And this one here, just the empirical formula. This is just the empirical formula. So if you look at the ratio, it came out to be 2. Don't worry about the fraction. Take the whole number. So 2. So what is the formula is? We said the empirical formula is CH3O1, correct? That's the empirical formula. Now you have 2 here. You have to multiply those by 2. So then the answer is here, which is, I draw for you that this is, I'm doing it with the mouse, it does not, and those are the hydrogens. So this is hydrogens all over the places. This is your antifreeze or antifreeze, whatever you pronounce it. So that's not the antifreeze, sorry, that's dioxide. Antifreeze is a glycol, that's alcohol. This is not alcohol. This is called an ether, double ether. See, that's ether. This one an ether. So that's dioxide. So let's go and look at the very nice subject, which look at the, will be used even for the next chapter, the formula. So what you will do here in this, please print this one out and keep it handy for you. So you don't have to go and spend some time back and forth, and the clock is ticking in the back. I'm not putting the clock in front, that's annoying, but there is a clock in iCollege. Some professors, they put the clock in front of the students, and that's not good because this makes students very anxious and they cannot concentrate, especially if you put the voice on it. So it tick, 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 tick all the time. It's not good. So I avoid this. Just make sure that's because you have to print it, because then in the final exam, ACS exam, by then you have to memorize most of those formulas. They'll give you very few formulas, not that many. They give you very few formulas, but you have to be able to have this one here memorize at least those here. Look at this. At least those here. This is the formula here, but you have to know what this formula is all about. So those are the formulas here, all those formulas, but you have to know what they are related to. All those formulas, you have to know what they are related to. All those formulas, you have to know what they are related to. So we'll do some examples because it does not make sense for us just memorizing them or just have them there handy without doing actual examples for that, correct? And that's what I'm telling you. You have to go to OWL, need to do those OWLs, because I'm not telling you hiding from you. I am using the OWL test bank, their website. So therefore, you can see my questions is related to whatever you have in the assignment. So I downloaded their test bank. Might be there are on and off errors, but you just pointed that to me. I just copy and paste. I have no time to look at all these questions. I just copy and paste, but sometimes there, and then I go check, they have an error in test bank. So therefore, you have to do the OWL. It's very important, OWL 2. So I have 2 students, they have still at large. 2 students, they have problems with the access. I hope that they will be resolved soon or so. But you need this because those questions will come. This here, at least a couple of questions in the ACS exam, final exam. I'm always relating our work to ACS exam. Why? Because that's where the 25%. So if you get all A's, and then you then 25%, you lose most of it out, then it's not good. But I curve the final exam because I curve it. So don't worry, I will curve it. So let's go for the next step. Here it is again. Here it is. That's the molality. That's the formula here. This one here, the milli equivalent, that's very obsolete. I mean, very old. It's pretty historical stuff. So We don't use it really. Use mole per liter. You go anywhere, if you work in the pharmacy, the back pharmacy, you do generic ones. Did you see that pharmacy do some generic medicine? Generic means homemade. So they have the recipe there, mix this plus this. They have purettes, automatic purettes, very decent. They mix samples and they give you the label on it is Walgreens or CVS or Walmart pharmacy. So those are called generic, homemade medicine, correct? They have the same effect like the ones you have at the brand name, but the brand name has double the price. So that's the difference between generic, but the effect is the same. So they have a procedure, they mix, then they give you the generic name. So we don't use equivalent more. I don't want you to spend, even I will not put exams questions for that. ACS exam through my 23 here in this, and even in Colorado 35 years ago, I did not see somebody is using equivalent, but at least you will know. It's not difficult. It's not really, you'll see, if you, I can show you some time, it's not difficult. But because it's obsolete, we'll not lose our time inside this. Dilution is very, very good questions, correct? And we have to know this formula here. All this, which is the same thing, just okay. So, and then the last one here. So you have to print those 3 pages, please, for your own sake and for the final sake. So this is, you'll know how to use those formulas here, correct? Equivalent molarities, we don't, again, equivalent we don't use. And then you do the dilution. And well, that's the same thing we did. So let's go for the third one here. And this is part per million, part per billion. That's not obsolete. That's very good. That's just used. But nobody is asking in ACS exam, but at least you will have the idea how to approach this. What's part per million and part per billion? So billion and million. So it's part of the million, part of the billion. So million, what's the power? That's the exponent of million. Million, what's it? 10 power 6, 10 power plus 6. So what we call this in a code? What we call this one in a code? That's a megabyte. So that's a byte. Mega means power 6 mega, correct? Megameter. Instead of kilometer, I say megameter. Meter is the basic unit, like a byte is the basic unit. Then I use mega. So how about billion? Part of the billion. Billion is power what? Plus 9. Plus 9, correct? Plus 9. Power 10 power plus 9. So that's very important. So what's the name of it? The code of it? What's the code of it? Somebody will tell me? Come on, guys. I said megabytes. I have gigabytes, correct? I have what? Gigameter, gigagrams. The basic unit will stay there. Grams, meter, correct? Liter, gigaliter. So giga. So what's next? It's not here. What's next? 10 power what? Now 12. What we call that? Correct. Terabytes, teraliters, teragrams. Correct? So what's the your external hard drive? The capacity of it. Oh, it's about 3 terabytes. 10 plus 12. Correct? So we have to know those things at least when you come to questions. So let's go and look at the others. Some examples now. The first example is mass over volume. The first example is mass over the volume. What is the mass volume percent by a solution formed by mixing 25 grams sodium chloride in 455 milliliters? Now you have to know the units is, believe it or not, the units is Somebody will say the unit is, what is the unit here? Somebody will tell me. Gram per ml. Yeah, this is gram over ml, the mass over the volume, and then parentheses 100%. That's the unit of it, correct? So that's the unit of it here. Gram per ml, 100%. So that's the unit of mass to volume. So we have grams of the mass of the solute. That's the solute, sodium chloride called the solute. And the solvent is 455 milliliter. You divide 25 over 455. You have to watch for the sig fix. This is 3 here, correct? This is 3. So your answer has to come. This is came from the calculator. See how many significant? That's too long. You have to get it into the it is. We have to stop here, correct? We have to stop here somehow. Take it. So we have to stop. Other one. So we have to stop on this one here. So this is one here. Look at this. So this is 9 rounded to 1. So it will be 5.50 gram per ml percentage. This is the units, correct? So let's take another example. Mass over the volume now. Let's take another example. This is calculate the amount of the solute, and the solution is made of a solute and the solvent. We'll come back to that in next chapter to look at the polarity. So it's a solution is made of, it is guys, a solution is made of solution. What is the solution? Yeah, you tell me it's made of solute here, solute over solvent, correct? This is the definition of a solution. Not over, but solute and solvent. Solvent, it is large amount, correct? Large amount. And this is small amount. They have to be mixing together. What is the solution then? What's the solution? Maybe this is the quiz. I don't know. I did not look at the quiz number 2. So solution, because they have to mix themselves good. So soluble in each other, soluble in each other. So I'm writing with the mouse. It does not write very well. The pen is in each other. So they are soluble in each other. So solution is what? Solution is homogeneous mixture. So this is very important to define the solution. A solution is mixture, and it's homogeneous mixture. A homogeneous mixture, yeah. Which not heterogeneous, but it's homogeneous mixture. So you look at this, made of a solute and a solvent, which they are soluble in each other. They have to be what? They have to be soluble in each other. So let's look at this one here. We have now. Let's look at this. This is a tricky here. They give you the percentage in advance. The percentage is given to you, mass over the volume, and they give you the volume of the solution, correct? And they ask you what is the calculate the mass of the solute, which is the small amount. So we have mass over the volume percentage equal to the mass you don't know, X, correct? And this one here, the 1 liter, correct, which is 1,000. It has to be in milliliters. You have to watch for the units. This is milliliter. So then you have, this will equal to, multiplied by 100, 100%, equal to 38, 38.5. So they give you the answer. What's the ratio, what's the percentage of the composition of this mixture here between solute and solvent? 38. So you just work to get your X here. That's what you need here. Your X, solve it for X. And that's what we did. 38.5 gram, that's the answer of the solution. X in the top, that's the mass of the solute. And then the solution is 1,000 ml. Multiply by 100, you get the 100 down, and you work it out for X. And X came out to be 385 gram potassium nitrate. The solute is 385. You can verify it. You take this mass here, divide by 1,000, 38. If you take 385, divide by 1,000, sorry, by 1,000, correct? 1,000 or 1 liter, correct? So if you look at this, 1,000, and you multiply it by 100, this is 1,000. Multiply by 100 to get the percentage, and you will get the answer is here. Correct. So if you look at this you can verify it. So let's look at another example. As I said, it will be worth to print out those pages, because then you have them handy and you know how to approach each one of those. So now, mass over mass. This is very tricky. Mass over mass, volume over volume. So this is tricky because you have to put the total amount of the mass of the solution. Here's the trick, and a lot of calculations. This is the trick here. Mass of the solution. So mass over the mass percentage is mass of the solute, a small amount. Mass of the solution is the sum of, here it is. This is here. Is mass of the solute plus mass of the solvent. Mass of the solute plus mass of the solvent. Now let's look at the example here. Another example here. So we have that's mass over mass. So we have a solution formed by adding 48 of lithium sulfate, 48 grams, 250 grams of H2O. Correct? So, well, what is the mass over the mass? Mass of the solute is 48, will come in the top, divided by the sum of 48 plus 250. And the whole thing here multiplied by 100. So you have to watch. Mass of the solution means you have to add the solute here, and you have to add the mass of the solvent, mass of the solvent. And it came out to be a large number, but you have to look at the this has to be rounded in 2, correct? If you look at this, this is 2 significant figure. This will come, I don't know what's the value here, but this will control the outcome here. Is the answer is gram over gram percentage, and this is 2 significant figures, 16. So let's look further, another example. Now we'll do another question. Mass over mass is given to you. So this one here is given to you. So this one is given to you. Given, correct? So this one is given. So given. So given. And it's asked about the they will ask you about the mass of the solute or mass of the solution, either or. It said grams made of this. This is given. This is here. This is 10%, 10.5. And then mass of the solution is by adding to nitrate. So it does not give you the amount of H2O. So it does not give you the mass of the solution, correct? So you assume the mass of the solution here, the whole thing is X. You don't know what's this, correct? We need to get the H2O. So, but this H2O is X is equal to mass of H2O plus mass of the solute. So mass of H2O plus mass of the uh, the uh, the solute is made of solution mass percentage aluminum nitrate. So what's the formula of aluminum nitrate? Al, correct? And NO3, polyatomic, 3 minus, but this one here, and the whole thing is 3. This is aluminum nitrate. So aluminum Al here, that's A, that's L. So now I don't know the X, so I have to set up the whole thing here together. The 10.15 is here. That's from the percentage. This one is my percentage, correct? And will equal 2 grams of the nitrate. That's given to me. The solute amount is given, but the solution is not given. Work it out, you get the X. X here is 19, correct? X is 19 grams. So what is H2O? Will be 19 minus the 2 of the aluminum nitrate. This is the amount of H2O inside this solution. So if you can verify it, add the 2 to verification divided by 19, 17 plus 2, 19, multiplied by 100 will give you this amount here. Correct? That will give you the mass percentage. So let's do another formula. As I said, this is neat practice. There is no, I mean, you can memorize the formulas, but without practice, it will be very hard. You have to practice those hours. So let's do for volume. So volume over the volume. So this is the volume here of the solution is the sum. The same thing with the mass. So here, look at this, guys. So this is the solute here, correct? Now this one here, the bottom here, is nothing less than the sum. This is the volume of the solute plus solvent. I apologize because this, so of the solvent, both of them. So anyway, so this is the volume of both. So the same thing with the mass over mass of the solute plus the sum of the masses of solute plus solvent. The volume over the volume of the solute in the top divided by the volume of both solute and solvent. As I said, you have to train yourself to do some calculations. I mean, I can give you the formula, but examples, but you have to do hour 2. It's very important. Very important to pass the ACS exam, to pass the quizzes and exam. This is very, very important. So now we have what is the percent by volume of a solution formed by adding ethanol 25 and H2O is 155 mils. Somebody will tell me which one is the solvent, which one is the solute. Somebody will tell me. So this is the small amount, correct? So this one will be what? Our what? Okay. This one, the large amount, will be our what? Correct. That's absolutely correct. Absolutely correct. That's solvent. and they are mixing with each other, and they make homogeneous mixture. They mix to each other, they make homogeneous mixture. So we need the percentage. So we put the volume of the solute, which is 25 in the top, which is here. We divide this one here. This is divide by the sum of both solute and the solvent. And then the answer is, the whole answer is multiplied by 100%. So if you look, it came out from the calculator, this amount here. So, but we have to look at controlling one. This is two significant figures, correct? And here, whatever is coming, it's coming 180, which is two sig figs. So our answer is two sig figs, 14%. Now, we can give you this one here. I can give you one of the, the answer, but you have to calculate. You have to calculate the mass of the solvent or the mass of the solute, correct? So here it is. I give you the answer here for you here, given to you. The volume over the volume percentage is here. This is the amount here. So this is 5.50. Adding certain amount of volume of solute. We don't know how much. So this, therefore, the solute is here, X. Divided by, the solvent is 250, 255, correct? So the solute is 255. So they did not tell you what's yeah, acetone and H2O. So this is the H2O is the solvent, 255, and the solute is acetone. So X is the solute again. You sum them out. So this is 5.50 divided by 100, correct? This one here is solve for X. So X will be 14.8 milliliters, correct? 40.8 milliliters. You verify it, you put this one 40.8 and the sum 40.8 to 255, and then the answer is multiplied by 100, you get 5.50. Correct, guys? So, as I said, you can have one is given and one is unknown, so you can work it out. So let's see. Now, what is molarity? We have molality and molarity. What is the difference between molarity and molality? It turns out to be molarity is a ratio between number of moles divided by liter of the solution. Number of moles divided by the liter of solution. How about molality? Molality with the L, not R, with the L. The molality is number of moles ratio, again, divided by kilogram of the solvent. See, there you have liter of solution. There you have kilogram of the solvent. So so molality is per mass, mole per mass, right? Per kilogram, right? So mole per mass, and the molarity is mole per volume, mole per volume. So that's the difference between them. So molarity is, and this is very important because you see it if somebody interested to go any lab work in the real life, you will have to know the molarity. You have to know how to calculate. Although it comes for you, the procedure, there, but please, you can verify it yourself about the calculation. So calculate the molarity. This is an example here for us. It said, calculate the molarity of a solution made of dissolving this, correct? Sodium chloride in that much milliliters H2O. We said molarity, the unit is mole per what? Liter, correct? Now, here we have a problem. We don't have mole, we have grams. So we need the sodium chloride molar mass. We need the molar mass of this, correct? So the molar mass is, what's the molar mass? Is equal to molar mass. What's the unit of the molar mass? Gram per moles, correct? Gram per mole. That's the unit of the molar mass. And how we get sodium chloride? Well, sodium chloride is made of sodium plus fluoride. So sodium is 23 and chlorine is 35.5 gram per mole. So you add them up and you'll end up having, I think is 58, yeah, 58, I think, 58.5. 23 plus 35.5, 38. So you need the molar mass. Why you need the molar mass? Because by definition, the molarity is given to you, mole per liter. You need the moles, but you have the grams here. So you take the grams here, you divide it by the molar mass of sodium chloride to get the moles. So this is first, we determined it came out correct. So it came out same thing. This is the molar mass of sodium chloride. This is sodium chloride. The molar mass is the sum of atomic masses of both, correct? Now, you have this, you divide the number of mass, 35, divided by the molar mass. This is number of moles, correct? That's you need to use. Then we have a problem with this amount of milliliters. We have to convert the milliliters into what? Into liters, because mole per liter. So we have to convert this one here, the milliliters here, into liters. So we have this amount of liter. Then at the molarity definition, this is number of moles from here, correct? Divided by the liters from here. And the units is very, very unique units. Of course, this is too long. We need 3 significant figures, correct? So this is the molarity here. It has 3 types of units. We have mole per liter. We have capital M. We have molar. So the units of the molarity, 3 units. So it has 3 units. They are meaning the same thing. 3 units. So they mean the same thing, right? Molar, capital M, or mole per liter. So let's look at the molality now. The molality will be very similar, except for the fact we are dealing with kilogram, not liters, but kilogram. Now, this is another example of molarity. So because the molarity is mole per liter, I can give you the moles. You can calculate for and liters. You can calculate the molarity, correct? So here it is, guys. You know that every formula you can make out of it more than one formula. So molarity here, capital M, is moles per liter, correct? So per volume. Now, can I change this one here? Yes. So moles, what will be moles? Another formula equal to what? Molarity multiplied by liters, correct? Can I get the liters? Yes. Liters are moles, correct? Moles divided by the molarity. So now you have you have 2 sub formulas from the main one. You have 2 sub formulas from the main one. Correct, guys? Let's look at this example. To us, it's given to you here. Take this one here. It's given to us the molarity of the solution, given us the solute nitrate, amount in grams. So whenever you get grams, then you have to use the molar mass of the solute to get the number of moles, correct? And then in certain amount did not give you the amount of solvent. So the amount of the solvent we did before, mole per liter equal the big M molarity. So the liters will be, if I want to get liters, so liters will be equal to, somebody will tell me, mole divided by, here, divided by the molarity. So that's the formula, the sub formula we just talked about. So let's look at this. Now, let's look at this again. we have magnesium nitrate. It has 8.5 grams. We need the molar mass of it. So the molar mass, one magnesium is 24. Then magnesium nitrate, nitrogen is 14, oxygen is 16. So, but magnesium nitrate, it has to be Mg. You have to know the formula. If you don't know the formula, then all your calculations is for the molar mass is not correct. So you can have the periodic table ready to you. That's the nitrate. Magnesium is always second, the second group will be 2. So Mg in parentheses NO3 subscript 2, 2 nitrates, 2 magnesium. So you calculate, and this is here given to you as well. So if you look like this one is given to you here. Look at this one here, magnesium nitrate, 2 magnesium, 2 nitrates. You do all the calculations, you will end up with the molar mass of magnesium nitrate is 148.3. Now to get number of moles, you have the mass divided by the molar mass to get the moles. So the moles are 366.073. So now we have the mole, correct? And as I told you, this formula is you mole per liter. So we don't know. So it's equal to 0.073 mole. So you have to divide by the liters will be, you divide the moles by the molarity to get the answer. And that's what we have done here. And the number came up too large number here. And we have 366, and it will come out to be so here it is. This is 3, this is 3, and it has to be verifying your answer. Now, somebody will tell me, is this correct or not correct? This is 366, this is 366, but I see here 2.67. That's not correct. It has to be 2.68. It has to be 366. Right? It has to be 366. So it's not really, it's not correct, but it's the significant here has to be 3. So let's look at another example. Another example, Avogadro's number can be used in some of those molarity stuff, especially in the lab. So here is given to us the number of the molecules of acetone in a solution is this amount. And we are making dissolved in this amount of milliliters. Calculate the molarity. Well, I need to get what out of this? The moles. So I use Avogadro's number to get the moles. So if I have those molecules here, so I will say, take this number here, 10, or 10 to minus 10 power, 10 power 26, correct? You divide by Avogadro's number, correct? You divide by Avogadro's number is molecules per mole. So you divide by Avogadro's number. See, 1 mole to this molecule will end up having, you have to divide it. So, and you get out of this is 6 point. So here it is. You divide all those, you get number of moles like this. Here, that huge number. Now, I have a question about this. A question to you: can I round in between when I make a significant figures? I will say avoid any rounding in between. So if you have 4 or 5 operation, you have division, you have multiplication, you have addition, and you have subtraction, all in one. The question is, what is the priority for those? The priority will come division, number 1, multiplication, number 2, and then subtraction, addition at the last. Are you following me here? Do not round in between operations calculation. You have to wait until the end of the processes of all those operations, and then you can round. So you can see you'll get good precise value than if you round in between. And that's what the test bank went into an error, and you cannot round in between. That's not good, because you get if you round each step, you can get a wrong. Keep all the numbers are there, and the end you can round, correct? So number of moles, that much of number of moles you have, and then the volume is then you have this is the liters here given to you. That's the liters 300, 3,500, and you divide the moles by liters. This is 4 sig figs, correct? 4 sig figs, and this is your answer has to be 4 sig figs. So your answer is capital M, or mole per liter, or molar. So each unit is correct. So as I said, you have to have those handy so you can follow. Now, molality. What is the difference between molarity and molality? Well, it turns out to be more molarity, moles over volume. Molality, moles over mass. So molality is defined kilogram of the solvent, so per mass. Molality, correct? We don't use molality that much, but when it comes to physical properties, some physical properties, they use molality here. So, for example, let's look at this. What is the molality of a solution made of this amount of grams? As I said, I can talk and talk and talk, but you have to do the owl. You have to do it, because without doing it, so it'll be very hard to follow the calculations. I gave you over 10, so you can't miss your assignment. So you have plenty of attempts to reattempt and reattempt and reattempt, correct? So what is the molality? So molality is moles of the solute over kilogram of the solvent. So we have, this is aluminum nitrate. Again, I have to write aluminum nitrate, Al. Then NO3. Okay, so that's the nitrate, subscript of 3. Because aluminum is +3, so you have to put 3 there. So we have the aluminum nitrate is the solute, and the solvent is H2O, gram. So I have to transfer this gram into kilograms. Correct, guys? 2 kilograms. This one here, I have to transfer it into moles. So I have to know the molar mass of this compound. I have to know the molar mass of this compound. So the molar mass of this compound is 1 aluminum, 3 nitrogens, and 9 oxygens, and you can just calculate the whole thing. So aluminum is 27, oxygen is 16, and nitrogen is 14. So you can do all this calculation, you will end up this molar mass. You divide number of grams by the molar mass to get number of moles. This is number of moles. Next step is to take the grams into kilograms. By dividing by 1,000, you get this. So this amount, those two here, you divide this moles by this gram, you get your molality. So that's what you get here. And the final answer is, the units is mole per kilogram, small m, or molar. So if I compare this one here with the molarity, that will be molar. I'll stop here. Molar and capital M and mole per liter. So I'll stop here, guys. Before I quit, I want just to let you know that there are extra credit coming. There are extra credit coming, and one of them is 25th of October, and whoever attending will get 10 points. And we have end of October, Halloween. If you are attending, will be in front here of the. I'll tell you. I'll put the flyers there. So this is a chemistry club, and we have science club activities as well. I'm in the science club and chemistry club. If you attend, you get 10 points, and we'll add it to your exams. So if you get, like, say 60, you have extra credit, about 45, and then you add those, all the 10 attendance, that will add to your exams. Okay, guys? Come back and finish this, and then we'll go for the second, for the fourth, number 4. No, I have to call them. I have to call them. I did not get anything. I did not get anything. No. God, you can use some of your friends. They have done to review for the quiz. No, not you can. You cannot enter your, but use the questions to read the questions. What the questions are all about. No, I can't because I can't. I have no way to enter them. That's the problem. I have no access to this. That's theirs. I have no access. Sorry about this. But you have to wait, and he has the same problem. So, yeah, you have to wait because